I'd like to introduce the law of cosines. When you have an oblique triangle, like so, with corner A, B, and C, side B, side A, side C, like so. When you have an oblique triangle and not a right triangle, you have to have three parts in order to solve the triangle. In other words, you have to be given three things in order to find the other three things. So you could be given three sides, you could be given two sides and an angle, or two angles and a side. Of course, you can't be given three angles because then you'd have all the similar triangles as solutions. So therefore, you have to have at least one side in it. In the previous video, we talked about the law of sines, which requires you to know an angle and a side opposite, or this angle and a side opposite, or that angle and a side opposite. So basically, to use the law of sines, you must have one of those three ratios. But supposing you don't have that, supposing you have this situation. For example, supposing you're given side B, angle A, and side C. Now you have side, angle, side. The problem is that you have an angle but no side opposite because you don't know that. You have side C, but you don't know the angle opposite, and you have side B, but you don't have the angle opposite. So therefore, you can't set up the law of sines, which says you must have the sine of A over A equals the sine of B over B equals the sine of C over C. So we don't have that. What do we do now? Well, what we have to do is resort to the law of cosines, which is a little more complicated arithmetically, but it solves those problems that can't be solved with the law of sines. I'd like to demonstrate how we develop the law of cosines. Just like in the previous demonstration, you drop an h just like so. Drop that down. And then what I'm going to do is something you've seen in algebra but you don't see often. I'm going to take this little segment right here, I'm going to call it x. And I'm going to call this segment over here c minus x. Now you remember from algebra, obviously if I make this x and this c minus x, then the whole thing is c. That's all it simply says. And I'm also going to call this guy up here, the height, h. And there it is. I've introduced two variables that weren't there in the beginning. In the beginning, all there was ABC and ABC. Now I've got this x and this h in here. So I'm going to show you how to use them, and then they're going to be used, and then they're going to be erased from the process. So the trick is, the way this thing works is, you put these two variables in, you do a little bit of algebraic magic, and then the two variables disappear, and you have your answer. It's kind of cute. So let's start off with this first triangle right here. Now that's a perpendicular. I want to mention that for sure. That's a perpendicular right there. So what you do is you say, okay, what is the cosine of this angle right here, angle A? The cosine of angle A. The cosine of angle A is equal to x over b, like so. Okay. What is the sine of angle A? The sine of angle A is equal to the h height over b, like so. Okay. Now, the first thing I'm going to do is I'm going to make this rearrange this equation so the thing I introduced is all by itself, and I'm going to put everything that we do know in the equation over here. So I say x is equal to b cosine of a. So basically what I'm saying is, this is the stuff we know. This is the variable I invented just because I wanted to invent a variable. And this right here, this h, I'm going to do the same thing. I'm going to put the h on one side and the stuff we do know on the other side. So I say h is equal to b times the sine of a. There you go, right there. So now that I've done that, I'm going to just forget this triangle, and I'm going to go over to this triangle over here. Now in this triangle over here, using Pythagoras, I know that this squared plus this squared equals that squared. So in other words, if I were to write that down, I would say a squared equals h squared plus c minus x squared, like so. That's what the Pythagorean would look like. The square of one side plus the square of the other side equals the square of the hypotenuse in this triangle right here, okay? And now, I do exactly what I said I'm going to do. I'm going to get rid of h by replacing it with this, which what we do have. And I'm going to get rid of x by replacing it with this. So this equation is no longer going to have x's and h's in it. Now it's just going to have the stuff that was given to us originally. So I say a squared is equal to h squared, and h is b times the sine of a squared, plus c, which that was given to us originally, minus x, and x is b cosine of a. That's all squared right there. And there it is. That's what the Pythagoras theorem looks like right here, using x's and h's, which have been now eliminated, and that's what you get right there. If I expand this thing out, I say that a squared is equal to b squared sine squared of a, that's just this squared right here, plus c squared minus 2bc cosine of a, that's the middle term of this multiplication, plus b squared cosine squared of a. And there it is. All that simply says is I took this and squared it here, took this and squared it there. Okay? So what I'd like to do now is I'd like to take this term way on the right here and move it up closer to the front term. And here's how we're going to do it. I'm going to take this, say a squared equals this term right here, and then this term right here, then this term here, and this term right here. Now that I've done that, the next thing I want to do is I want to factor the b squared out of these two terms right here, and I'll show you why. As soon as I do it, you'll see what will happen. So a squared is equal to the b squared factored out times sine squared of a plus cosine squared of a, plus c squared minus 2bc cosine of a. Now, the thing is that everyone knows this turns into a 1 because of the identity. Sine squared of an angle plus cosine squared of an angle equals 1. So therefore, all you're left with is the b squared. So you end up with a squared equals b squared plus c squared minus 2b times c times the cosine of angle A. That is the first expression of the law of cosines right there. What it says is that this unknown side right here, A, this unknown side A, is equal to the side you do know squared plus the other side you know squared minus 2 times the side you know times the side you know times the cosine of the angle. In other words, the only information that you need is this side, this angle, this side, to find that side. And that's what this equation does for you. It's called the law of cosines. And that together with the law of sines, which says that the sine of angle A over A equals the sine of angle B over B equals the sine of angle C over C. These two laws together, this is the law of sines right here, these two laws together will allow you to be given three sides or two angles and a side, or two sides and an angle of any triangle that's oblique, and you'll be able to find all the other sides and angles. And that's pretty much it. That's how it works.